Hello, everyone. I'm going to take some time to go through Lab 10, seafloor spreading. And this lab has three components. You have this Word document that I have up right now, an Excel spreadsheet for the last part of the questions in the Word document, and this PDF that it gives you figure 1.2. And then the rest of it is really for the last part of the lab. Now, within the Word document, it references that you might either print uh, the figure 1.2 image, or I'm telling you, you don't necessarily need to print it. You can just look at the image closely and make observations and then interpretations. So this lab has a fair amount of just reading through to help you answer the questions. Here again is figure 1.2. So we have Africa, and we have the mid-ocean ridge, and we have South America here. And we're looking at figure 1.2. And like I said, you can print it. I'm not a huge fan of printing if I don't have to, but you could lay a piece of paper over it and trace the shorelines. But I could trace it as well with my eyes. So this would be the western shoreline. And then you could trace this part of South America to answer this question. The question is, how well do these different points fit together? Right? Points A and E, points B and F, points C and G, and then points D and H. Are they a good fit or a poor fit? And then the next part of the question, again, if you have it printed, you could lay a piece of paper over it and trace it and kind of move the Africa shoreline over the South American shoreline, or excuse me, the continental shelf, and see how well they fit together. This continental shelf is the lighter, shallower area of the ocean floor that you see. And we're asking how well these appear to fit together. No need to print it unless you really want to. You'll also be looking at like the shades of blue in the South Atlantic Ocean. Darker the blue color, the deeper the water. So we're asking you what is the deepest part there? Where is the deepest water? And then still using this image, either from this Word document, or I would suggest you use the PDF and zoom in, because what we need to do is zoom in on the mid-ocean or mid-Atlantic ridge, another way of saying the same thing. And you're going to be looking at the zigzag patterns, right? So I can zoom way in and make observations about the area around I and J. PDF is good like that. Your printer might not give you the best resolution anyway. So use this to answer those questions. All right, so you'll go through these questions. I do think that each question sort of builds on the next and guides you through some basic math. So if you have any issues with that, just send me a question pertaining to specific parts of each section and I can help you out with that. This one here, we're going to go through magnetic anomalies, and all the figures that you need to answer the questions are within this Word document, and they're referenced like figure 2.1, figure 2.2. And you're really just making observations on the orientation of the magnetic stripes. So nothing super technical. It's just looking at the orientations, what do you see? And your answers might vary a little bit, and that's okay. Now we're getting into magnetic reversals. And there's some background here. We talked about this early on in the semester with plate tectonics. But you'll be using like figure 2.4 to answer questions 5 through 10. And again, each question sort of builds off the other to a degree. Part 3, again, read through this background. You have everything you need within the Word document to answer these questions, like figure 3.2. But what I want to point out for this last part, hopefully not going too fast, this is where we start to use, once again, the PDF and now the Excel sheet. And what's great is the answers that you need to input into the Excel sheet are right in the PDF. So let's see. If I look at question 4, look at the information for site 16 in the PDF. Now, what are these sites? Let's look at that. Zoom back out a bit. There we go. Okay, so this is the context. We're looking in this area. And just like the plate tectonics lab, we're representing seafloor age and seafloor spreading in millions of years. MA means millions of years ago. It's represented by color, and the legend is here to show you. The youngest seafloor is, of course, along the mid-Atlantic ridge. We zoomed in on that box. This is site 16. We know that based on this color correlated with the legend, it's gonna be, well, close to 10, around 10 MA. Site 15, 10 to 20 MA, then you get 20 to 30. It just gets older the further away you get from the mid-Atlantic ridge. But to get the paleontological age of the different sites, you just look at these cores. This is 38 MA. That's for site 14. And then the distance west of the mid-Atlantic ridge is 745 kilometers. We were talking about site 15. So that was like 24 MA. And the distance west of the mid-Atlantic ridge is 422 kilometers. So you're going to take the age, paleontological age from here and input it into the Excel sheet, and then the distance as well that I just read off, you put that into here. You do that for each of the sites as described. Right? They're all in here. Site 16 is in here. You got your paleontological age, and you've got your distance west of the mid-Atlantic ridge. Got site 19. You got your age and your distance, right? So go through those, fill that out. And then to complete this part, okay, you're still using the data from the PDF. You'll find as you get the age and the distance data entered into the Excel spreadsheet, what happens is that you'll see points plot on this chart automatically. And if you don't, let me know. It could be something weird with your software or operating system. I'll help you work that out. But you're going to see some sort of trend, and you'll answer a question based on what you see. And then the next part is you're going to determine the rate of seafloor spreading just by entering a formula in cell D5. That would be equal to C5 divided by B5. Rate equals distance over age. So just point it out. This is cell D5. And you'll be putting that formula into here. And that's referencing this and, dividing the distance over time. All right, not too bad. And you will kind of answer your question based on what you see from that. The last thing you'll do is enter this formula, the average formula. You can copy and paste it or type it in, of D5 to D10. And then whatever you get for that will be the answer to number 10, right? So you'll be putting it in here. You're taking the average of this column once you have your data filled out there. And that is the entire lab. As always, if you got questions, let me know.